Hey everybody. Today we're doing the limit comparison test. This test just formalizes our intuition that when two series are very similar, they should either both converge or both diverge, even if one is a tiny bit larger or smaller than the other. Here it is a bit more formally. Suppose we have these two series with positive terms, sum of an and sum of bn. We're going to look at the ratio of the corresponding terms, an over bn, and ask, what does that do as n gets large, as n goes to infinity? If that ratio settles down to a finite positive number, c greater than 0, less than infinity, then the two series have the same behavior. They either both converge or they both diverge. For instance, sum from n equals 1 to infinity, 1 over 3 to the n minus 1. This is very similar to the convergent geometric series, the sum of 1 over 3 to the n. That has a ratio of 1/3 and therefore converges. However, it is a little bit larger than that series, so a direct comparison doesn't do the job. Let's try it with a limit comparison. So I take the ratio of the corresponding terms. I'm going to do 1 over 3 to the n over 1 over 3 to the n minus 1. By the way, it doesn't matter which order I do them, which one I choose as an and which one I choose to be bn. Either order works. It's just a matter of convenience which one you pick to be which. Simplify that limit a little bit. Write that as 1 minus 1 over 3 to the n, basically breaking up that fraction. And now the 1 over 3 to the n goes to 0, so I just get 1. So the limit comparison test says that these two series have to have the same behavior. Since the second one converges, so does the first one. By the limit comparison test, the sum from n equals 1 to infinity, 1 over 3 to the n minus 1, converges. The limit comparison test is useful in a wide variety of circumstances, but it particularly shines when you've got a rational function for your general term, one polynomial divided by another. Or something similar to a rational function, where instead of a polynomial, we just have n to a power, like 1/2 or 1/5. Here's a good example. The sum from n equals 1 to infinity, n squared minus 2n plus 1 over n to the 4th plus n squared plus 1. So the numerator has degree 2 and the denominator has degree 4. So as n gets larger and larger, we know that only the highest power terms are going to matter. So this is going to look like n squared over n to the 4th, basically 1 over n squared. I expect this series to have the same behavior as the sum of 1 over n squared. That's a convergent series. Convergent p series with p equals 2. So let's do a limit comparison test using the sum of 1 over n squared. I do the limit as n goes to infinity, n squared minus 2n plus 1 over n to the 4th plus n squared plus 1 over 1 over n squared. Multiplying by a reciprocal, I get the limit of a degree 4 polynomial over a degree 4 polynomial. I can do this with L'Hopital's rule, or I could factor n to the 4th out of the top and bottom and start canceling stuff. Either way, I get 1. So the series that I'm looking at is going to have the same convergence properties as the sum of 1 over n squared. They both converge in this case.